Hi, Dan. I have been waiting to have a chat with you for a while because you are somebody who has spent 30 years working on a problem. And suddenly the world became aware of AI. It feels like overnight in November of 2022. And I can't wait to discover what that was like for you and what you've been working on since, and also before that. So, why don't you take a second to introduce yourself and let us know what you do?
Sure. Hi, I'm Dan Bikel. And yes, my day job is as an AI research scientist. I also go by the moniker of an NLP researcher. That's what I've been doing for a really long time. The way you put it makes it sound like I was either stubborn or crazy to work this long in an area, maybe a bit of both.
I mean, both of those things can be very good to be. So,
Yeah. So yeah, I've been doing, as I like to tell people, I've been doing this long before it was cool.
the cool people tend to be working on stuff and being into things before they were cool. So, let's talk a little bit about this. Yeah, it's stubborn and crazy, but it's also being singularly focused and very driven by curiosity. But before, you got your PhDs and working at all of the big guys in tech. What was the first complex system or puzzle that just grabbed you and made you hyperfixate, maybe as a kid? And how does that connect with your journey so far?
I think I have two answers to this. One is a little more connected than the other. The first one that's maybe less connected is for me, music has always been a huge part of my life. So that was like this fascinatingly complex system that involved something that's deeply subjective and emotional, but also you can work things out in almost the same way that you can puzzle through complex challenges like chess or something. So it has this broad range of aspects to it that was really cool. And I just took to it from a really early age and
Like really early. Like
like really
you were
early.
6 years old, right?
I was about six or so. I think that's when my father was a professional musician, amongst other things, and gave me a guitar. And I taught myself how to play guitar. And then I started teaching myself how to play piano and I would sing and started writing music around that age. So yeah, it was pretty early on. So that's like something that is, endlessly fascinating and endlessly fun to work on. So that was maybe one of the first things. But also, surprise, surprise, language was always like a very salient topic growing up. My father spoke five languages fluently and another couple really, really well. And my mother was at one time a news reporter and a TV news producer. And so both of them were extremely well read, extremely erudite and knowledgeable about language. So we would routinely have debates about etymology at the dinner table, discussing, the origin of words.
Like the typical American family does.
Yeah, yeah. So language was also this fascinating thing. And then when I started on these, what would now be extremely primitive computers, programming them and seeing that, very early on, I saw like an early version of this famous program called ELIZA, like every linguist and every computer scientist knows about because it was like an example of how you could use a few clever tricks to make it appear that you had a chatbot that was somewhat intelligent or responsive.
Yeah, I remember trying to chat with Eliza back, but this was like, I didn't treat it like it was an AI experiment or anything. It was like, oh, cool, chatbot. Let's trick it into saying something weird because
Yeah,
I was, an immature. I don't even know how old I was, but I was
yeah.
immature.
Uh, so was I, but it was super cool that you could have this, thing that was programmed that kind of sort of simulated something that looked a little bit human like. And through only a few clever tricks, it was a really small program, but it could do this. So that was kind of one of the early things that I saw and played with. And then I started just diving into programming computers and getting lost in making like text adventure games and things like that.
The common theme that I've noticed, and I mean, it's like a duh moment, right? Is this NLP slash machine learning? There's the linguistics pipeline to this discipline that is fascinating to me. And it's a little bit envious for me because I wasn't exposed to that STEM aspect, but I was always a language nerd from the beginning. I remember finding like a used Latin book in some random bookshelf and just being like, oh, I want to, I could decipher what it meant just from the recognizing the root language, right? So etymology, all of that kind of stuff, I deeply relate to it, and understanding like origins of words. I've spoken with Melissa, who is on your team. I've spoken with Umar, who used to work for Writer, and Wasim, and everybody said that there was some kind of linguistic fascination or frustration that they were puzzling out when they finally took the leap into machine learning, NLP, AI. Is there a story like that with you?
No, it wasn't born of frustration. It was luck in the sense that I majored in college in classics, ancient Greek and Latin. So when you learn those two languages, you cover about 98% of English roots. So I can play that etymology game. I used to always be, it was like a delightful surprise when I encountered a word that, I didn't know the origin of because of that. But every classicist is kind of a closet linguist, and I was no exception. So I applied to the four technology companies that were hiring at the time. This was at Harvard. Yeah, it was only four. And one of them was this funny little research lab that was down the street in Cambridge called BBN. And they had this lab that did research on this field I'd never heard of called computational linguistics or natural language processing, and it was combined with the people who did speech recognition. So I ended up getting a couple of job offers, and that was one of them. And I took that one rather than the one that was for more money because it was a research position, and it seemed to combine two things that I already loved. Like it combined computers and language. And I was like, oh, that's cool. There's a field here. Amazing. And BBN, it turns out, was this amazing place with a long history of great research in all sorts of areas, including speech and language. So yeah, I just sort of stumbled into it, and then I was off to the races.
Was there a core challenge, line of research, something that you and your team were investigating back then that maybe now is kind of like, oh, well, that's not a big deal anymore? Or maybe it's still a big deal.
No, pretty. It's funny identifying the things that are no longer a big deal. So the main thing that I worked on when I was there, a part of it is definitely no longer a big deal at all. So I was building one of the earliest examples of a statistical method for identifying named entities in text, which is basically just finding the boundaries of named entities and figure out what type of thing they are. And in the early days, it was like there were only 7 types. It was like person, organization, location, and some numerical quantities, and not much else than that. And then eventually the types got to be more and more interesting.
As a layman, it's kind of like the animal, vegetable, or mineral game. Is that right? Or it's like categorizing, recognizing words and categorizing them?
It's not just categorizing, it's finding the boundaries of them. I'll give you the easy example. The easy examples are when you see, say, a person's first and last name. That's usually pretty easy. There are a lot of clues that allow a model to figure out, even a primitive model like the kind we were building back then, that, yeah, this looks like a person's name. But it gets more interesting and harder when you think about, first of all, the range of possible names is really large. You can't just look this up in a list or anything like that. And there are plenty of times when a first name looks like a regular word. And so,
Or a last name,
yeah,
as we
exactly. Right. So what happens when that regular word appears, as the first word in the sentence, right? We work at a company whose CEO is May.
right.
Well, that's a perfectly good modal verb also. So you want to make sure you're building a system that is robust to the recognizing what's the difference. And so it has to find the full extent, like the full boundary of any name entity and then kite it. So some of this stuff is like totally easy now relative to the way it was back then. And people have been building rule-based systems. You had to build a different set of rules. It was very brittle anytime you moved to a different kind of text, let alone to a different kind of language. So one of the earliest things that I was able to do was build a statistical model to do this type of thing, but the models didn't care what the training data looked like. So we had to solve this problem for English and Spanish, and we just fed in Spanish training data, and suddenly we had a really decent Spanish named entity recognizer. It was sort of the promise of machine learning, like, oh, it just is defined by the training data. Just feed it to the training procedure, and you'll spit out a model that can do what you need it to do. So at the time, that was kind of tough. It gets really hard, by the way, when you have a phenomenon called metonymy. So oftentimes you'll notice people refer to the seat of government by a location, like Washington announced that it was doing such and such a thing, right? So identifying that correctly as a location or a geopolitical entity is tough. That could be really hard, right? Or a sports team.
Every time we talk about these type of problems, I just imagine AI like this truly literal thinking alien, that you're just like the cultural nuance and way that we frame language is so profoundly complex. And the fact that we can train this digital entity to grok that is just amazing to me.
That we can do it at all. The basic form of this problem has become, I think, so good that we don't tend to see no real new research in this area anymore.
Mhm.
But there are versions of it that still persist, like trying to do entity disambiguation or entity identification. Like there might be many people, I don't know, Michael Jordan. There are at least like three really famous Michael Jordans out there.
Mhm.
There's a basketball player, but there's
Michael
a
B. Jordan.
professor,
Mhm.
there's Michael B. Jordan. There's a bunch of them. So doing that problem, that's still kind of hard.
Yeah, I mean, if you did a Google search, it would be the same type of spit out. So being able to comb this massive corpus of data and just being like, oh, this is the context of this Michael Jordan. Yeah, that makes sense. I mean, that's just a tiny nugget of one of the problems that you've been working on over the years. You've worked at places like IBM Research and LinkedIn, and I would like to hear about what type of stuff they did back then. This is the 2010s. What did it look like to be an AI scientist working at one of these larger companies? And what did it feel like? And what do you anticipate the difference is now?
Life felt a bit slower back then. There wasn't like the frenzy that it sometimes feels like there is today. And that was largely a good thing. There were still places in industry, like industrial research labs that were built in the mold of doing academic style research. That's not prevalent at all today, or not nearly as prevalent as it used to be. So IBM research was one of those places.
It's old school. Yeah.
Yeah. And it was a really cool thing. Like, even the building was built at a time when there was no open office seating, but everyone, out of egalitarian reasons, everyone had an office. It was very tiny, but everyone had the same size office, same size tiny office. And it's strange to talk about this today, like office, who has an office? But it was really amazing. It did not prevent collaboration. It was, if anything, it was super cool. One colleague might come down the hallway, enter your office, and you start chatting at the whiteboard. And then two more colleagues enter your tiny office, and it couldn't fit more than about that. Maybe, you'd be jammed in like sardines, but having these amazing conversations without bothering other people
Mhm.
usually. So it was, life was a little bit more like it is as a PhD student in a university in industrial research lab back then. We would read papers and sometimes discuss things that were far afield from our field. Like IBM especially, it was like 2,000 people ish at the main research facility in Yorktown Heights, New York. And it was like the world's largest engineering school. It had chemistry folks who were doing basic research because IBM was in the business of designing and building new methods for fabricating chips. And one of the coolest things, actually, like in my first week there, I was just wandering the halls and saw this gigantic room with an impossible array. It looked like a caricature of what people would imagine a scientist's room would look like. Like, it was tons of equipment everywhere, and there was a guy in a white lab coat, and I was just like, "Oh, this is so cool!" And I
You
wandered.
have arrived.
Yeah, I know, right? I wandered in the room, and the guy who was there. I was like, I'm sorry, I'm new here, but could you tell me what that is? There was a mammoth machine in the middle of the room. And he looked at me, sized me up, looked at the fact that I had a badge, so I belonged in the building. He was like, yeah, sure. And then he proceeded to explain that he was building a new advanced version of a scanning electron microscope and was showing me some of the new scans that he had just taken. And, we were looking at, things as small as atoms. And I was like, yeah,
You were nerding out is what you
yeah,
were doing.
yeah. I've been doing that for forever, but yes,
Yeah.
I continued on my journey of nerding out, and so it was super cool that way. It was equally likely that we could be reading papers in natural language processing, but also hearing lectures on like pure math.
So it's like this bastion of research happening on one hand, and then talk to me about LinkedIn because this is 2010s. It's the emergence of social media. That's more of a startup world than your industrial research. What was the culture shock like, if there was any?
There was. I mean, I came from Google Research. I went down the street. I'd been working in Mountain View at the time, and that's where LinkedIn was. So, like, they hired me to be a senior individual contributor to help build and lead an NLP team for the entire company because they didn't have one at the time. I had tons of text flowing through the platform. I don't think it really dawned on me that I had joined what was effectively a social media company until my first day of orientation. I was like, wait, what? Oh, that's right. This place does this social media thing. I know it's almost embarrassing to admit now, but it's true. I was like, oh, I'm just going to do what I do and like help solve problems and understand text. But it represented a phase change for me and for basically from my career and in a lot of ways. So I came from this sort of academic style, industrial research place. Google Research at the time was kind of like that, a little more applied, but still had plenty of basic research going on. And then coming to a place like that, which wasn't a startup, but it was 3,000 people. 2.25 years later, when I left, it was 11,000. So it was growing fast. I quickly realized A, I was at a social media company. B, it didn't have a giant language research or research division at all. So I had to make this mental shift. And I realized my job was to go out, see what the business problems were, and then work my way back to what is the research that we should be doing to support those business problems, to somehow feed into what the business needed. It was like a complete reversal. Like I was used to this more academic style of like, well, there are so many cool problems. I'm going to pick a few of them and drive headlong and make an argument for why we should be working on this. And instead, I was like, no, 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 we can't just pick any old problem that's really cool to work on. We should look at what it might be needed. Now, within that space, it's still huge. There's like an immense amount of problems you can choose to work on when you look at, well, what does the business need? But from then onward, I think I've been most inclined to actually do that. And it was like a phase change. Like I suddenly started working that way and it was exhilarating and fun and interesting. And I had to get used to it because it wasn't like, oh, I'm just embark on a 5-year journey. It
Right.
was like, it might be like, I'll embark on a 1 to 2 year journey and hopefully deliver something in 3 to 6 months, along the way.
When you work in that type of approach, I mean, here's the thing with research, because you don't really have a time limit to it, you never really meet the boundary of it, right? You never really think, well, it's not worth pursuing this, or we're not going to crack this. But when you do have a business imperative behind it, there's got to be a stopping point where you're like, okay, this is we can't really invest more time or money into this. Can you give an example of a situation that's led to that?
Like when the business imperative necessitates stopping at some point, I think there comes a point where you either need to stop working or see it as kind of an evolution. There's like this distinction between going from 0 to 1 and then taking that one thing you've built and making it a little better. So one of the biggest projects I ever worked on actually was at Google. It was originally just two other guys and me started a project that was designed to do semantic parsing. And this was, you can think of it almost as like a big brother problem of the name entity thing I mentioned before, but where you're trying to take in a query coming in and decide what is the purpose of this query and what are the bits of information that are needed to make it to give the user what they need. So as an example, you might have a query come in that's like, send email to Alora with the subject, I'm running late for the meeting, and the message, I'm so sorry, but I'm going to be about 5 minutes late. Right? You can say all of that really easily in natural language, all in one fell swoop. And you got to gamify that as like, oh, that's one of these requests where the user wants to send an email and the important bits are the subject line and the message. Kind of straightforward, but not completely because you have to get the boundaries right. Harder still is like, set up an appointment where you have to name all the people that you want to come there. Like, oh, I set up a meeting with Alora. The subject of the meeting is timelines, and the date will be on the 26th. No, make that the 27th. And oh, by the way, also add Frank. Right? That's another way you could say that. And there are myriad ways. So we worked on this problem and got it to a point where we knew it was far from perfect, but it was one of these launch and iterate type of scenarios where at the time we launched it, it was for Android voice actions, basically saying stuff to your Android phone. Eventually it became the basis of the assistant, the Google Assistant, and all of search actually. So that project was an example of recognizing that there was a stopping point of the main bulk of the work, which is we got it to work. And then a lot of the work was getting it to sort of scale outward. There was a strain of research to sort of make it the core of it better. But a lot of it was like, oh, how can we expand this to work on many domains? And that was kind of the challenge there. Yeah. So I don't know if that captures what you were looking for.
I think it's also a matter of like getting a glimpse of like, oh, there's this line of inquiry that we could follow, or maybe you reached the limits of what you could research at that time, and maybe now
Oh, I can.
it's like exploded, you know?
So I'll give you another example. I one of the things that I worked at both when I was at IBM and then ended up working at on again at least once, if not twice, when I was at Google was event understanding. And this was a problem of essentially figuring out who did what to whom and when and for how much, or simple events like I say events, by the way, and people think different things. Some people think like, oh, we're planning a concert. It's not that type of event. It's more in the linguistic type of event where there's something that's happened and it has a temporal extent to it. Anything that's happened. So in a business context, it might be that company A acquired company B for, $100 million. That's an example of something that has happened, and it has a few important things like what is company A? What is company B? How much was the transaction that occurred? Right? When would that transaction occur? So at the time that I was working on this at IBM, the technology we had was good enough to make headway, but insufficient, I think, to make this truly useful. And at some point, we kind of had to cut our losses and just say, for various reasons, like we're not going to continue to invest a lot more in this particular. The area survived, by the way, as a research area. There were papers being published, et cetera. But at some point, we just had to say, okay, this is kind of reaching an asymptote in what we can do right now. And I ended up working on this very same problem almost when I got to Google, almost the larger version of it, where we're trying to understand. You can think of it as all verbs everywhere and their arguments. Like every sentence, there's something that's happening. And it gets more complicated and more interesting, like attribution becomes interesting. So imagine news text. According to the New York Times, so-and-so said that something happened. And so now you've got the thing that happened, and it was according to so-and-so, according to the New York Times. And there's like this
Right.
chain of attribution that you have to understand. And so I worked on that version of the problem there, and also kind of bumped up against the limits of the technology we had at the time, where it was good enough to make its way into certain products, but not good to be sort of released for everyone everywhere. And yeah, so we had to make the call like, okay, this is as much as we should do right now. There's like, a time when you have to call it and say like, well, there are others who are going to do this work. We don't have to be one of them.
You're now working for a company that delivers technology to large businesses. So we have a business imperative to serve other business imperatives. For decades, careers have been built on mastering predictable systems. And now we are dealing with these non deterministic, although I heard you say that they are deterministic, and I want to talk about that a little bit more.
Yeah.
Still, we have in our hands this more probabilistic machine and the greatness and the risk that comes with it. And I want to hear from you. You came from this world and now you're seeing how people in the business world grapple with it. And so from your point of view, what do you think they need to know about this technology? You're a native of it. What do you think is like the one thing they should take away as they go into this transformative moment with AI?
There are a couple of basic things. I don't know if I would narrow it down to one thing, but let me give like two things. It is true that it would be hard to point to any business person who would want to release into the wild a system that solves one of their business problems that is unpredictable. And a system whose characteristics change over time is really hard for a business person to say, yeah, sure. So that does indeed constitute a gigantic challenge. The point that you had heard me say earlier was that a large language model, at least sort of the vanilla version of a large language model, the model itself is deterministic. But here's what the model is doing. The model is giving you, given all of the previous words so far, this is like for the standard variety of LLM that we use today, given all the context, what is the distribution for the next word? That distribution is deterministically determined by all of the previous words. So that's what's deterministic. The way that they're often used is by putting this stochastic sampler on top, this thing that is sampling from that distribution with randomness.
To make it more novel.
Yeah, to
Yeah.
make it more human-like. And we can vary the amount of randomness in that sampler depending on what we want to achieve. And sometimes we say, don't do any randomness at all. Just pick the most likely next word. We do the greedy search. And for some problems, that's exactly what you want. When I've said this to rooms full of business people, most of them, if not all of them, have raised eyebrows because they didn't know this aspect of it. That, wait, you're adding randomness on top of the thing?
And it's the temperature, right? We're talking
The,
about.
the temperature is the parameter that we typically use to control
Mhm.
the degree of randomness. Exactly. That's normally a good thing to know. A, that it's controllable. Like maybe they've heard of temperature. Maybe they play with it even. But maybe they didn't know that, like, oh, fundamentally, the model is deterministic, but the way we're using it is often with randomness. The other thing that it immediately makes you want to work on is the ability to constrain and characterize what these models are going to do. That's a big part of what we do. It's a big part of what we're doing right now at Writer. It's like trying to make sure we have ways of evaluating the models we're building so that we can at least put some reasonable bounds on what we expect the model to do, what the output distribution should look like. And the more we can do that, I think the better it is for customers, for any business customers anywhere doing anything with LLMs. The more we can characterize the models that are at the core of the systems, the better. It's sort of a cop out to your question a little bit, that we might have various ways of measuring this and trying to constrain the outputs in such a way. So we'll turn it on its head. I mentioned like, well, no sane business person would want to deploy a thing that would change over time without their understanding how the changes work, right?
Mhm.
So, but that's the crucial bit. It's like, okay, but can we build a thing that does change over time where you can have some certainty or some understanding at least of the way that it's changing over time? And that might be really, really valuable. Something that is adaptive, but in a constrained way that we can at least still guarantee that it's still performing, the tasks that you want it to perform in the way that you'd like them to. So that's also like actively what we're working on here at Writer. And we're not the only ones, but we are definitely working on that type of thing. And it's, there was a reason why self-evolving models was an effort and why we're even taking what I would consider an even larger step in that direction to get systems that are adaptive over time and yet still have the right degree of predictability and understandability that they're not going to wander off in a horrible direction. There have been a few like notable public incidents of this happening where gigantic company launches a thing that learns on the fly from the internet, and then the
Mhm.
internet teaches it awful things, and then suddenly it's spouting awful things. Like nobody wants that now, right? And so that's like an active area.
So when we talk about language models, AI, a lot of times to me, it almost feels like especially in the business context, that we're trying to harness. It's not a natural force, but it behaves like one in many ways. Just like you can predict the patterns of the weather, but you can't perfectly predict them. Ultimately, there are algorithms at work there too. And I think that's the fascinating part of this science and technology, and also a frustrating part of it, because we are trying to harness it. Is that a point of inquiry for you?
I mentioned how it's always interesting to find business problems and work your way backwards. And typically the set of research problems you can, it's constraining, but not overly so. Like the set of fascinating research problems you can think about is still really, really big. One of the areas that is of direct relevance to businesses who want to build these LLM based systems or use them is the way that you can get a large language model, which fundamentally is good at representing language and good at generating it and mimicking the sequence of words a human might spit out, getting them to do what they do best, but crucially have a good interface between those types of sequence prediction problems and the more symbolic reasoning systems that we have that are so good at their problems. Code generation is an example of this, where we would like to be able to generate code that is executable and that is doing the right thing. And it's kind of amazing that large language models, that they're as good as they are at this problem, but they're not compilers. They don't actually compile and execute the code. They generate it and then we can check. And so that's an example of how you can get this sort of sequence predictor that's really good at natural language sequences, but also trained on tons of code and can spit out a sequence of things that looks like a really well-formed program. And then sure enough, it is. And sometimes it isn't. And you got to fix it. And sometimes you can get the model to fix it. Sometimes you have to fix it. But even more fundamentally, it's the interplay between large language models and those types of models and symbolic reasoning systems. Even if it's as simple as a calculator, calculators are extremely small pieces of computing machinery, really, really small. I like to tell anyone who listen that the dumbest way to build a calculator is to train an autoregressive large language model on 10 trillion words of text. You could get a model to add two numbers, maybe add three-digit numbers, maybe most of the time, well, four-digit numbers most of the time, well, five digits.
Supposedly, but then people joke about, oh, they can't do math.
Right, but they can't. And it's because they're not designed to do that.
Right. You're using the wrong tool. Right.
So you'd be much better off figuring out how can you get an LLM to output the sequence of tokens that then can be further processed and dealt with by a symbolic reasoning system, whether it's a theorem prover or a calculator or a compiler. And so this is like of direct relevance. And that interplay is really a fascinating area to me. Sometimes it goes by the name of neurosymbolic research, but there are other areas that are fascinating. So that I think is directly relevant to business people who want to solve business problems, because they often have discrete moves they want to make, but you want to be able to harness this incredible power of a trillion parameter large language model. So let's try and do both and get the interplay to work well.
Now, we're going into the agentic age too, which complicates things and adds even more areas of inquiry. We just came out with our white paper, the Agentic Compact. One of the main things we talk about in it is transparency and explainability. And I would love to hear just a quick understanding of how agentic impacts this sense of transparency and explainability. Model transparency, model explainability is something that research has been working on for a while. And now we've got agents coming into the picture. So, can you give me a quick overview of what you've been looking into and what people are talking about?
Sure. So transparency is more about the ability to characterize the model or the system that you've built around it before you've even done anything with it. And it's trying to understand, well, how is this thing built? And can we sort of characterize it a priori? That often involves the things that people have been working on in the field for some time, like trying to document or at least characterize the data that you're using to train with, the methods, perhaps the nature of the model itself, the methods you're using to do pre-training or post-training. And I talked a little about this before, but like evaluations that help you characterize what the outputs might look like in inputs, and work on safety, which is something I've worked on in my previous job, and it is relevant here as well, everywhere. Characterizing, how safe are you with respect to the various axes? And there are tons of them. So that's transparency. Explainability is and observability are super critical, I think, when it comes to this age of agents. Agents calling each other, or an agent calling itself repeatedly, and calling tools and then calling itself repeatedly. Precisely because now we sort of have this combinatoric explosion. Before, we had an input sequence and we were trying to generate an output sequence. And that's hard enough. And now we've got, wait a minute, you're telling me that we've got that, but now multiple agents are calling each other and generating multiple output sequences in the course of solving a problem. This becomes devilishly hard. Some of this is like traditional good software design practice of making any system we're building should be maximally observable. Sure, we can do that. We can build in all the requisite logging to make it so we can figure out what happened, where, and when in this sort of complicated procedure. I think we can solve some of the problems of explainability in an agentic world via this extension of what we already do in the simple case. So if we think of an agent, like action agent, solving a problem in multiple steps, we can still characterize what should happen at each step and build evaluations even and training methods that are looking at those interstitial steps, those steps in between that we're trying to optimize for and trying to observe. That's part of it. The other part is, what does observability mean? It's very tempting to use a large language model to explain itself. And that's really cool. You can ask that large language, hey, why didn't you come up with that answer? And it will spit out something. But it's doing what it's been trained to do, which is spit out a plausible sequence of tokens that you would believe are plausible.
Yes.
And not necessarily say, oh, but this is what was going on inside the model exactly. So we can still use this method to some good effect, but there's other really fascinating work on trying to more directly tie outputs to what was actually going on inside the model and or tie them directly to training instances even that the model was exposed to. The combination of those two is where we've got to go. We can make use of this sort of self-introspection, which is really just spitting on sequence of tokens and shouldn't be relied on too heavily.
Fingers crossed that it's actually telling the truth, right?
Exactly. There's no guarantee. There's just the only guarantee is that it's spitting out the sequence that's plausible. But then if we couple it with things like citations, where we as humans can go back and check, and couple it with being actually able to understand, well, what's going on in the model itself, in the activations, and how does it tie back even to training data, then we've got something super powerful. So this is still active work, but that's where we need to go.
Oh no, it means that you're going to have a job for a while.
Yeah.
That's job security.
Knock wood. I mean, it seems like it. There's still plenty of hard problems out there. That's for sure.
And that's good news.
Yeah.
I think for anybody who loves to be a curious person, that's a wonderful problem to have. Actually, one of the questions I had as you were telling me this is there a world in which there will be agents created to do that line of inquiry or explainability challenge?
Like an agent whose job it is to help explain the work of other agents?
Yes.
Maybe. We've been here before when we try and calibrate a model. The one thing that a model can't be trained to use is its own score for something. So we often end up building a different model based on the scoring of the first model. And that's like a baby version of what you're describing.
I know that with the synthetic data approach, for example, right, you have a model that's trained to kind of
A reward model. We'll build things
yeah.
like a reward model or a verifier as we help train models. But yeah, so that in a way, you could imagine that type of approach being extended to help have one model or agent monitor others in some fashion, because it might have access to things that they themselves could not possibly have access to, or wouldn't be as feasible to do it any other way. So yeah, it's conceivable. I think we're a ways out from that, but I also don't want to predict, like a ways out might mean like, we're a full 3 weeks away,
Right,
right?
right?
Or
In this
whether it's
world.
3 months, or 3 years, but we're N weeks or N months away from doing that.
All right, so one last question, Dan. I was going to actually ask you what still gives you a sense of wonder, but everything that you've talked to me about, I can see fills you with a sense of wonder. But I'm curious as to what you would tell that little nerdling growing up who was picking up music and playing around with computers. What would you say to him?
I think I would offer words of encouragement for one thing, especially when I sort of embarked on my proper sort of adult scientific research career is when you're on like an exponential curve, it looks like things are happening really, really slowly, sometimes for a really long time until you hit the knee of the curve. And the problem is you don't know when that knee will occur. Is it going to be 100 years from now or 1,000? You don't know. You could just be, 1,000 and boom. And then that's how these curves often work. So if I could have told myself that the knee, it seems like we're in the knee of some kind of curve of progress, maybe kind of sort of. So if I could have told myself that the knee is actually going to occur in my lifetime, that would have been a strong sort of motivation. Like I kept working at the same field anyway, right?
Yeah.
But suddenly it seemed right around, especially the 2010s, like around 2015 or so, whenever Elmo came out. Elmo was the thing that predated BERT, that predated T5, that predated the other forms of like GPT and the other forms of large language models. And that blew the field out of the water. Suddenly we were doing so much better on so many problems. And I was like, well, we're not going to see that kind of improvement anytime soon, but it was a huge improvement. And a year later, BERT came out. And I and either all of my colleagues were like, oh my gosh, we see another breakthrough. It's been a year and it was just kept snowballing. So if I could have known that that was going to happen, that's incredibly energizing.
Yeah, it is.
Hard to know when that might have happened, but it did. And so it would have been cool to know like 20 years prior, like, yeah, it's going to happen. It's not
And
as
it's
far
going to
off.
be two Muppet names, by the way. Uh,
Yeah. Elmo embeddings from language modeling. That's what it stood for. And then like, how could you not follow that with BERT? So yeah,
Amazing. Thank you so much, Dan.
thanks very much.